de presentaros a no solo a un médico muy competente, sino a un gran amigo. Y por eso es realmente un gran honor para mí tenerle aquí con nosotros. Paul Gringas es licenciado en Medicina, es consultor médico en Guy's Hospital en neuropediatría, donde lleva a cabo sus trabajos clínicos y sus trabajos de investigación. Paul siempre ha tenido un interés especial en el tratamiento médico de los niños dentro del espectro del autismo. Sin embargo, a lo largo de los últimos 8 años, sus trabajos se han dirigido hacia el estudio de los patrones de sueño de los niños dentro del espectro del autismo y de los niños con problemas de sueño con otras patologías psiquiátricas. Está muy interesado en el tratamiento conductual de los trastornos del sueño, al igual que está interesado en el tratamiento farmacológico, y creo que va a presentar las últimas investigaciones, los últimos trabajos que ha hecho él en Guy's Hospital. Paul, durante la primera hora, nos va a hablar exclusivamente de los trastornos del sueño, pero lo que nos ha hecho es, nos va a aportar información sobre la comorbilidad psiquiátrica del síndrome de Asperger con ciertas patologías durante la última media hora, un poco por compensar el hecho de que Gilbert no haya podido venir. Entonces, la primera hora va a hablar de los trastornos del sueño, pero la última media hora lo va a hacer él ya como él quiera, va a dedicarlo a la comorbilidad psiquiátrica del síndrome de Asperger con 2 o 3 patologías que ha traído y que está basada en los estudios que han hecho ellos en Guy's Hospital. Y sin más, le paso la palabra al doctor Gringas. Paul.
Thank you, Pilar. Es un honor estar aquí para hablar de los trastornos del sueño, aquí en el país de la siesta. Me disculpo porque el resto de mi discurso será en inglés. Así que intenta estar despiertos. Thank you. Thank you. That was the difficult bit for me. And the easier bit. I work at the Evelina Children's Hospital. It's opposite the London Eye and the Houses of Parliament. So come and visit next time you are a tourist in London. And that's the hospital by day and by night time. The Sleep Disorders Unit has been working for about 8 years, and we see about 800 children each year. And because we have a particular interest in children with Asperger's syndrome and autistic spectrum disorders, about 1/3 of those children fall into that category. The 4 aims of this talk, because it will be a long afternoon, so just 4 aims really. One is to convince you all that sleep has a vital role in early brain development. Some people say, well, it's the other way around. Brain development needs to be normal for sleep to develop normally, but it is two-way. Both are important. And sleep problems are particularly strongly associated with autism, Asperger's syndrome. And this is different than all other developmental disorders, where the sleep problems are associated with the learning difficulties or with the comorbidity. That's not the case in autism and Asperger's syndrome. There is a unique association, which is very strong. I'm also going to be pointing out that there's no one sleep disorder that's uniquely associated with autism and Asperger's syndrome. So, unfortunately, many aspects about the biology and the psychology and the genetics of Asperger's syndrome and autism all come together to make these children and adults vulnerable to a range of sleep disorders. The good news is that most of the sleep disorders are amenable to treatment. And it's one of the few areas, I believe, where you can make a difference to the whole family. And it's very encouraging sometimes to see a child and a young person come back and the whole family have changed in 1 month, okay? We're going to have a quick journey learning from sleep deprivation studies so I can convince you about how important sleep is. First of all, in adults. Wonderful work has been done, mainly by Stickgold and Walker from the US. They've looked at memory and the impact of sleep deprivation on memory. And there's the hippocampus glowing nicely on functional MRI studies. With a good night's sleep and with a bad night's sleep, memory gets much worse, both procedural and declarative memory, and there are changes that are measurable on functional MRI studies. The same applies for learning a motor task. Ignore this for a bit and let me just describe a motor task. If I asked you all how quickly you could react to an image on a computer screen and you practiced, you would get better this afternoon. You might take 4, 5, 6 times, but then you would reach the peak of your performance. You'd be reacting very, very quickly. If you then go to sleep tonight and have a good night's sleep, tomorrow you will do better on that task. So everything grandparents tell you about needing a good night's sleep is true. You learn, you remember things, and you can react faster. However, if you have a poor night's sleep, particularly the last quarter of the night, missing out on either dream sleep or non-dream sleep, your reaction time gets worse. And sleep's important for emotions as well. So many of you might know if you have a very bad night's sleep and you're tired, the next day you feel a bit more sensitive, a bit more paranoid, worried about things, more anxious. So there's evidence that the amygdala and the regulation of the amygdala coping with fearful and anxiety stimuli changes after poor sleep. And the interesting thing is there's a relationship in some of the brain studies of children with Asperger syndrome and autism where the same part of the amygdala is affected in recognizing faces, fear. So this is all clues that sleep has an intimate role to play in people with autism and Asperger's. It's not proof, though, because this is sleep deprivation, and that's artificial. So let's move on to why do children sleep? Is it worth it? And a bit of, this is an excuse. This isn't neuroanatomy. This is an excuse to show you pictures of babies. Okay? And here's a baby remembering about apoptosis, programmed cell death that's so important in very early development in the first few months. And here's a baby that's very intelligent, remembering about axonal path findings, the way that cells migrate like cars on a monorail and seem to know how to get to the right place. This baby's clever as well. And he knows about dendritic proliferation, the growth of favorable nerve impulses that have a useful function, and then myelination, which is when everything speeds up. And myelination happening mainly in the first 2 years of life, but we know that there are processes of myelination that are still taking place in the early 20s. So why bother with this? Well, the reason is that in the first 2 years of life, the average baby is asleep for 13 months. So sleep is the dominant state in the first 2 years, and it's the dominant state while all this important brain development is happening. Now, if we did an experiment that would not be ethical in England, and we covered this baby's eye, this baby's right eye, what would happen would be there would be rapid remodeling. So all the impulses coming in from the eye that's not covered would enlarge at the back of the cortex, the occipital cortex, and the baby would start to adjust. This is brain plasticity, okay? So this happens rapidly for young children. Unfortunately, it happens much more slowly for people of my age. Now, if you made the experiment even more unethical, and you put a patch over this child's eye, and you kept the child awake and you sleep deprived them, none of this remodeling would happen. Okay, so sleep is crucial in the synaptic development and remodeling and pruning that is necessary. And we are, in this conference, talking about children, young people and adults who are vulnerable already. And we know that there are many genetic origins to this vulnerability. And so the impact of sleep added to this is likely to be very, very important. If you want to do sleep deprivation experiments in children, this is an American term, slumber parties. So what you do, you have to invite children to a party. And you have to say, would you like to come? And you can stay up as long as you want. And you can watch videos and you don't have to go to bed. And you get lots of volunteers. And nice children, and I did this in Chicago for one night, nice children come along to be tested. And we test them on reaction time and mood. We use the CBCL. And they stay awake till maybe 4 in the morning. The following morning, those nice children have been replaced by oppositional, ADHD, challenging children who don't want to cooperate in your experiments. And all the parents in the audience will know this, okay? Now, it doesn't have to be dramatic. So a researcher called Avi Sada in Israel, in Tel Aviv, deprived school children of just 1 hour less sleep than they normally get for 1 week. And he didn't tell the teachers which children had been deprived of sleep for just 1 hour a week. And the school teachers got it right every time on measures of verbal creativity, abstract thinking, working memory, many of the areas of executive functioning that you've heard about quite a lot at this conference already. And in children with autism, although we've not specifically sleep-deprived children with autism to have a look, the association is very strong. There are many case reports talking about self-injurious behaviors getting worse. Obsessions and perseverative behaviors in children with Asperger's syndrome being worse when their sleep's worse. This is just one study showing that the good sleepers with autistic spectrum disorders had fewer affective problems and better social interactions than the poor sleepers. So this isn't proof, but this is a suggestion that this is an important association. So what I want to do today is take you from bedside, from the stories that mums tell us about their children, and from the stories that children and young adults tell us, to some objective measurements. So this is something called an ActiWatch that records movement, that allows us to look at sleep cycles in the child's home, moving and drilling further down to using polysomnography, measuring physiological channels of sleep, and what this tells us about autism. Further still, to many, many EEG and statistical ways of analyzing EEG. Does that tell us about sleep and autism? And we'll touch on dreaming as well. And finally, looking at genes, and this is an Illumina array that allows us to look at about 1 million little pieces of the human genome. So we'll be following this route. In order to understand the impact of sleep deprivation and sleep behaviors during the day, because I believe this is crucial, it's not just about the nighttime. Are we affecting daytime behaviors of children? We've had to develop computerized packages that we think explain the symptoms well, so that the children and young adults themselves can tell us about their symptoms, side effects, and quality of life. I'll be talking more about this in the next talk, so I won't dwell on it further. Okay, so just how common are these sleep problems that I'm talking about? Well, it depends what paper you read, but it's about 50%. So in about 50% of children and young people with Asperger's syndrome, sleep problems are going to be a major area of difficulty. And that makes it significant and worth treating. And I'll talk at the end as well. There is evidence that these are long-term. There are many clinicians in England that believe that these children grow out of it. But that's because they've never asked adults properly, okay? We'll also be looking at, once you start to do investigations, you find that the parents aren't underestimating the rate of problems in this group. In fact, the problems are more common than parents realize. And then when we go down further to look at the actual architecture, the physiological makeup of sleep cycles, it is different in children and in adults with autism and Asperger's syndrome. In our clinic, so we looked at the last 300 referrals with Asperger's syndrome to look at what type of sleep problems were coming up most commonly. And you'll see the yellow ones are the most common ones. Sleep onset insomnia, a long time to fall asleep. Sleep association problems and bedtime resistance. So this is where there's more of a behavioral element. This is where the parents will say, okay, just one last book, but in fact, the child's already had 40 books. There's sleep fragmentation, when sleep is broken up throughout the night, and this is very common. But you'll see there's a large number of sleep disorders as well. So no one sleep disorder that's unique. And what that means is you can't have one treatment that's going to work for every person with Asperger's syndrome and sleep disorders. You need to define what's happening with the sleep disorder. So the first group, and pediatric sleep medicine is easy. It's children who don't fall asleep, it's children who do unusual things in the night, and it's children who are too sleepy during the day, that's all. So that's why my job's sort of quite easy. Children that don't fall asleep, maybe it's sleep onset insomnia, many reasons, and they are unable to switch off and fall asleep. Maybe it's bedtime resistance, behavioral problems. And I'll talk about later, the other explanation is delayed sleep phase. These children's sleep rhythms have gone wrong. And more on that later. But now the first two, sleep onset insomnia and bedtime resistance. These are primarily behavioral, and I need to emphasize that even with medications and even with advanced investigations, basic behavioral management should still be used and works. In my clinic, I work with a fantastic clinical psychologist who does a lot of the work. So, and even when there's a physiological cause or a genetic cause for a sleep problem, there is an associated psychological learned behavior that's involved the whole family. So treatment of sleep disorders from the behavioral perspective is, there's a whole range described. There are the extinction where you leave the child or the young person, or it can be done more gradually. There we are having to use for some of the young people with Asperger's syndrome a style of CBT. It's not quite proper CBT. It's focused on fears and anxieties in a language that they can understand and not overinterpret, and it can be very effective for sleep problems as well. What's the evidence? Well, the evidence for behavioral interventions is as good as the evidence for any medications, okay? So that's why we believe that behavioral interventions should come first. The effect size is good. There are a number of studies, and even, in fact, children outside the autistic spectrum who have autism and learning difficulties, behavioral interventions are still effective for that group. What we find is the most helpful thing in any behavioral intervention is the use of a telephone. Our psychologist will set up a program for parents, but then on about day 3 or day 4, when parents are ready to give up hope and the child's got a little bit worse, pick up the phone and we will encourage, we will see how things are going and offer strategies. So many phone calls, and in many occasions we can have success. But important to realize that we don't have success for all aspects of sleep disorders. We are often not treating the child's sleep. We might be helping the child stay in bed and not disturb parents, but that doesn't mean we are always changing the child's sleep. If we look, a lot of the research from Amanda Richdale's team in Australia has looked at which interventions work, and this is building on this. We find that disruptions before falling asleep, and maybe if a child won't sleep in their own bed or has night wakenings that are disturbing, those are very amenable to behavioral interventions. But a child that's just taking 3 hours to fall asleep, a child who's not sleeping long enough, one who's waking early in the morning, or who has unusual behaviors during the night, usually behavioral interventions are not successful, and it's not fair to put parents and families through behavioral interventions for those type of sleep disorders that probably won't respond. Okay, so we're going to move on from behavioral to some of the problems with sleep architecture itself, with the actual formation of our sleep, which goes in cycles from slow wave to dream sleep. So here's a boy getting wired up for a polysomnography study. So on his chin, it's recording the tone of muscles in his chin. Under his nose, airflow in and out of his nose. Around his head will be many more electrodes, recording EEG and telling us about sleep stage. On his neck, telling us about snoring. On his leg, EMG, to look at leg movements in the night. Round his chest, telling us about breathing movements of his chest and abdomen. And there he is. He has an oximeter on his finger. And this is all videoed. So here's our poor sleep technician who has to watch 6 studies all night, overnight. And perhaps the most incredible thing is that children do fall asleep at all with all these wires stuck to them. But they do. Sometimes we need 2 nights because the first night the sleep is so disrupted by the artificial environment that it doesn't tell us anything real. And you can see why you don't want to do this investigation without a good reason. So we don't do it on all children. We do it on a small percentage because it's labor-intensive, it's difficult for the child and for the families, but sometimes it's essential. So the sort of findings that are consistent across studies are that children with Asperger syndrome take longer to fall asleep, they wake up more, and there are specific difficulties in parts of their sleep cycle. One of the areas is during the slow wave. This is not dreaming sleep, but it's very interesting because that distinction is becoming blurred. We do dream in non-REM sleep, in non-dreaming sleep as well. So this has been discovered sort of recently, and the interesting thing is during this period of non-REM sleep, this is when children with Asperger's seem to have less of the sleep spindle activity and therefore probably have less dreams. And also during REM sleep, it's during the time when our eyes are moving rapidly that we are possibly scanning the content of our dreams, and children with Asperger's do that less as well. So there's something different about sleep architecture that's fundamental to having Asperger's syndrome and that links in with dreams as well. There are many different ways of analyzing EEG studies, and it's too technical and too late on a warm afternoon for me to tell you about that. But there are differences in both symmetry, so what side of the brain is affected, and in the actual content of different EEG spectra, different frequencies, that are looking quite good at actually differentiating children with Asperger's syndrome from control children. It's not a 100% science because, like neuroimaging, the populations are mixed, and if you look across different studies, it's not always consistent. But taking it one stage further, spectral analysis is now looking interesting. This is telling us we are able to look at the different regions of the brain that express different EEG frequencies. And again, this is telling us, it's a clue that sleep and sleep architecture and symmetries within the brain are different for children with autism and Asperger's syndrome than controls. So if one looks at dreaming, the thing that we understand now is that in REM sleep, we often have dreams of quite negative content. And the dreams that we have during non-REM sleep are often more positive. Okay? And in children with Asperger's syndrome, if you want to do dream research, there is no way of doing it apart from seeing the young person for a sleep study and waking them up in the middle of a dream and saying, what have you been dreaming about? And the software for writing down the narrative and coding the emotional content, the motivational content, the negative emotions, and in fact the emotional content, probably as you would expect, is very much decreased in Asperger's syndrome. Now, of course, there could be two explanations. It might simply be that they lack the communicative intent, the ability to translate the emotions they've experienced in their dreams into words that we can understand as a narrative. But it might be that they are genuinely getting less of the type of sleep that lets them have that dream, and the dreams having a different emotional content. And that is the more likely story. No more on dreams, because we're moving to light and we're moving to jazz music. Okay, so why jazz music? So this is Miles Davis. You all know that, I hope. Well, it is Miles Davis. And he wears sunglasses, and all jazz musicians wear sunglasses. And they don't wear it for fashion, to be cool. They wear it because when jazz music started, the musicians used to do concerts late at night into the early hours of the morning, and they all had to work the next day because they didn't earn enough money from the music. And they were under bright lights on the stage, and therefore the next day found it hard to fall asleep for a few hours before they had to go to work. So the story goes that they realize when they wear dark glasses, there's less light coming into their eyes, and for reasons I'll explain, they found it easier to fall asleep. Now this old technology is now being used for shift workers, for example, who wear tinted yellow glasses so that they can sleep better during the day. But this is just a window into explaining what I'm going to talk about, which is light, melatonin, autism, and genes. This is as complicated as I will let it get. So light is coming into our eye. We have special receptors, not for color, but special receptors for the amount of light called melanopsin receptors. And an impulse travels along a retinohypothalamic tract, and that impulse is eventually going to send a signal to the suprachiasmatic nucleus. So on the bottom picture, it's called the suprachiasmatic nucleus. It sits on top of the optic chiasm where signals from the eyes cross. The third ventricle is in the middle, and so this is the suprachiasmatic nucleus is contained within the hypothalamus. And the staining, in fact, is simply reflecting what happens when you expose someone to light during the night. So here's the important bit. Light switches off the mechanism that tells us when to go to sleep, and darkness switches that on again. So melatonin, which is produced by the pineal gland in response to signals from the suprachiasmatic nucleus, melatonin is a hormone of darkness, okay? And that's possibly, the important message. So we'll be coming back to melatonin because I understand in this country it's due to be licensed in a few months. In the UK, it's been used for many, many years. So I will share our experience using melatonin, as I think it's quite an important medication to talk about. So the children that don't fall asleep, we've already spoke about sleep onset insomnia and bedtime resistance, but this is the group with delayed sleep phase. These children, young people and adults, are jet lagged, but living in the country, okay? Now, there are many markers of our physiology that tell us what time of day it is, that reflect the body clock, okay? One of them is core body temperature. So you can see this is why in the middle of the night you feel cold sometimes and shivery. Growth hormone secretion occurs mainly during the first bit of the night. Cortisol levels change and melatonin levels change. Now, this yellow line is happening at 9 o'clock in the evening. So melatonin levels are quite low, but just starting to increase. And this is what we call the dim light melatonin onset period. So if you read papers that talk about the dim light melatonin onset period, it's simply a way of looking at an individual's body clock and saying, where is their sleep phase starting? When are they starting to get tired? And then through the night, as it progresses, by midnight, you're getting a bit colder. Melatonin levels have reached their peak. If you have delayed sleep phase syndrome, all this is moved to the right. So you're not producing melatonin at 9 o'clock. You're producing it maybe at 11 or 12 o'clock. And these young people will say, I am not tired and I can't sleep. So there are clock genes as well that make the story more complicated, and I'll talk about one of those later. Delayed sleep phase is worth talking about because it explains, as you saw earlier, about 40% of the sleep problems in people with Asperger syndrome and autism. So I'm going to tell you how we treat it. In order to document it, we ask parents to keep a sleep diary for about 2 weeks. Less than 2 weeks is not enough to detect just random variation, and more than 2 weeks, parents forget. Okay. We use actigraphy. It's like a wristwatch. It has a movement sensor inside it, and it allows us to know when someone is asleep and when they are awake. We sometimes measure the melatonin production we can do this from salivary swabs, just saliva in their mouth, looking through the night. And how do we treat it? Well, we start off by saying no sleeps during the day, and the morning wake-up time has to be constant. This is very important. Chronotherapy means that we move the time that they fall asleep, and I will explain what exactly we do. And we use light therapy a lot. So a very bright light early in the morning helps to suppress their melatonin levels and reset their body clock. Sometimes we use melatonin as well, a low dose of melatonin to further reset the body clock. Now, when I talk about chronotherapy, this is an important concept. If you see someone with autism, Asperger syndrome, who has delayed sleep phase and they're not falling asleep till 1 in the morning, you will not be able to get them to gradually fall asleep earlier because their body clock isn't pushing that way. It's going longer, not earlier. So we do the opposite, and we ask them to stay awake for 3 hours longer every night, which sounds crazy. And so the parents say, well, 3 hours longer, so they'll be eating during the night, they'll be sleeping during the day, and they will, but they'll only be doing that for 1 week or less, and at the end of it, they will be back on track. They'll be falling asleep at the normal time, and let me show you. So this is what actigraphy looks like. It looks a bit of a mess, but don't worry, because the black bits are lots of movement happening during the day and during wake, and where it's flatter, then there's less movement, and the computer algorithms tell us whether that's sleep or not. So look at the green line. This represents when this was a boy of 12 years old that had been told that he was school refusing, okay? He said, I'm not school refusing, I just can't wake up in the morning. So he was in fact not falling asleep till 6 a.m. every night. And the watch told us this, the history didn't, because his parents were asleep at that time, and he wasn't too good at explaining exactly when. So we told him to go to bed 3 hours later every night, and that would bring him round to the right time. And he did it very, very well. So you can see, here he is, and a week later, he's now falling asleep at about 8 o'clock in the evening. Perfect, for the first time ever. But the difficulty is now fixing him, anchoring him there, so he doesn't go the wrong way again. So we gave a little dose of melatonin, 0.5 milligrams in the evening, and bright light in the morning. And you can see that fixed his body clock, his sleep clock. He went back to school. He's now in college. It was a successful treatment, and he's happy, and his sleep phase is settled, okay? We see some more complicated things in autism and Asperger's syndrome, and this is a 9-year-old girl who appears, this is what we call free running. So her sleep-wake cycle is not related to the day outside. It's not related to light. We see this in adults who have no vision. So this is a picture we'd expect in adults with no vision, but her vision is perfect. She has Asperger's syndrome, but her vision is perfect. And this type of sleep cycle suggests that there's something wrong with one of the body clocks. And in her case, which we're looking into, there's a specific part of the body clock called PER3, which is just one of the mechanisms within the human body clock. And it's very interesting. It helps divide us up into those people that are night owls, that work very well late at night, like the whole of Seville, or morning larks that are, I have to wait for the, or morning larks that are very good first thing in the morning, okay? So there's a polymorphism of this gene that accounts for that, and we see it more in the children and adults with Asperger's syndrome that are falling asleep without this body rhythm. But more about melatonin and serotonin, because this is where the story gets very interesting, because across 4 good studies now, there is a correlation between children with Asperger's syndrome having lower levels of melatonin. So they have higher levels of serotonin and lower levels of melatonin. And we know about how melatonin is synthesized. It's made from, so 5-HT is the same as serotonin. And there are 2 enzymes that break down serotonin into melatonin. One of them is limited by light, and that's one of the rate-limiting steps. But the other enzyme, ASMT, this is the one that in some children with autism and Asperger's syndrome, there are mutations within it, there are polymorphisms, and it doesn't seem to be as effective in converting to melatonin. So levels are lower. The slides get more complicated, and this is wonderful research done by a very big international group. Thomas Bougeron is the geneticist at the Pasteur Institute who's done a lot of this work. So this is just one family. The mutation in the area that codes for ASMT, the mutation is present in the child, the proband, and the mother, and they have very low levels of melatonin all day. And if you remember from that picture I showed you, melatonin levels normally go high, reaching a peak at midnight. So the father, he's fine, and he doesn't have this mutation, and the mother and the child with Asperger's do. And their sleep history is interesting as well, because they say, well, we sleep okay, but we can sleep at any time of day. Yeah, so during the day, during the night, they don't get anchored onto any time of day. So this is possibly going to be an important area that we'll be hearing more about, that if you lack this enzyme, and you lack it more in autism. However, this picture is never 100% simple, as you've heard in this conference. So there are many children with Asperger's and autism who have normal levels of this enzyme as well. It doesn't account for all the problems. It might be very important in brain plasticity. It might even be, and this is a suggestion, that in some cases, the problem with melatonin and problems with sleep precede the disruption to the brain circuits that give us an autism or an Asperger phenotype. So it's chicken and egg, as we say in England. It's hard sometimes to know what might come first. Now, pharmacological treatments of sleep problems, this would be another whole lecture, and I don't have time. So this is a paper with an overview for a whole range of pharmacological treatments. I, today, will just very briefly review melatonin on its own. It's not the only medication. We can look at individual children using actigraphy, and we know that melatonin helps them sleep longer and more efficiently. There have been open-label studies, and there have been randomized control studies, very small ones, that are all suggesting that the children who have problems falling asleep fall asleep quicker when they take melatonin and sleep for a bit longer. Trials have got bigger, and so this is a trial of 50 patients. It was a crossover trial, and it found that on average they were falling asleep 30 minutes earlier, okay? Which is important if you're a child taking a long time to fall asleep, and sleeping longer. And if you remember the impact of sleep deprivation for just 1 hour a night, for 1 week, if you can achieve an extra half hour of sleep every night for the rest of a young person's life, then it's significant for brain development and cognitive development. So in the UK, what was happening? Well, we surveyed 1,900 children that had been taking melatonin, so that's an indication as to how much it's being prescribed. And it was being the most common clinical condition was Asperger syndrome and autism. The dose range was frightening. Some people giving 0.5 milligrams, and some people giving up to 24 milligrams. So nobody knew. Everyone's guessing. And for a range of sleep problems as well. After trying behavioral interventions, we hope, and after trying sedative medications. So this isn't good. We had a problem in the UK. Widespread prescribing of melatonin to children with Asperger's and autism without any robust, strong trials that gave us confidence that, number one, it works, and number two, it's safe. So it's a bad situation in the UK. So a trial was started 2 years ago that we are now 2/3 of the way through. It involves 12 centres in the UK, and is looking at over 300 children. It's a dose-ranging study, so because we don't know the dose of melatonin, we're beginning with 0.5 milligrams, and it escalates during the trial to 12 milligrams. Because we think behavior is important, all the children, for 1 month, when they are enrolled, have behavioral interventions, first of all. And interestingly, 40% drop out of the trial, because they are improving on the behavioral measures. So that's our first lesson, that what we believe about behavioral measures is important, and even in the most severe sleep disorders, behavior makes a big difference. But then the ones who still have problems are randomized to melatonin or placebo, and we want objective measures. So they're all wearing an ActiWatch, we're measuring the salivary melatonin, and we're looking at impact on daytime behaviors. Okay, for the children, and then we're also looking at impact on how the parents feel as well. Because maybe with some of our treatments, if we don't change much for the child, but we have parents that have a better mood, are more able to go to work, are less likely to crash their car because they're so tired, then we've still achieved something. So these are all these secondary outcomes. If you want the results of this, you have to invite me to Portugal for the next meeting, and it should be ready. So, this is just the last 2 slides of the sleepy bit of this talk. Why do all my adult general physician colleagues and all my adult psychiatry colleagues tell me that the sleep problems disappear with age. Well, so two good studies that have looked at this. One, parents give up telling doctors because they've not been listened to, and so they just give up. We always complain about sleep, no one does anything, so they give up. Another thing is, they simply stop reporting it, or the young person or adult stops complaining, so their sleep is still poor, but they're not talking about it because nobody's asking them. And that's borne out by these. These are just 3 studies, different age ranges. The first one, 12 to 24 years, showing that sleep efficiency is much lower in young people with Asperger's syndrome. Night wakenings are more common. The next study in 20 to 35-year-olds, okay, sleep efficiency much worse still at that age. And finally, at 16 to 27 years old, the time to fall asleep is still worse. So there isn't evidence that without treatment, these just get better with age. Okay, I'm going to stop there. I need to say thank you to various people. I need to say thank you to, on the left-hand side, my 2 sleep technicians who work very hard. And I need to say thank you to the men's group in the UK, which is the group doing the research we spoke about. In France, Professor Thomas Bougeron, who's done a lot of the work at looking at the sleep genes and is collaborating with the men's study. And in the USA, Stephen Sheldon, who's a sleep professor who taught me everything I know in Chicago and is following up this area as well. So I'm going to leave you with a picture that's called La Siesta, so that made me happy, but with an English quote from William Shakespeare, who says that sleep is the chief nourisher of life's great feast. I don't quite understand what it means in English, but I think he's right. Thank you very much. Yeah, do you want me just to go? Okay, the next speaker is me again. Sorry. So have a shake and stretch. I don't have any more Spanish introductions this time for this talk because I said I would do this because